guys, this is Virat and today I am going to teach about the this importance of back EMF in the DC motor in DC motor. So what is actually an back EMF? It is the voltage which is created in the motor due to the interaction between the armature current and the stator magnetic field, and these two interaction builds often back EMF in the DC motor. Now we are going to learn about some significance of back EMF in the DC motor. Is it actually necessary, or is it beneficial or not? Okay, when we now make a simple DC motor, let's make shunt DC motor. As we know, there are different types of DC motor. Now take an example, shunt DC motor, and its equivalent circuit would be like this, and this, and this is the primary source, and this is the field winding, and inside this is all we call as armature, and the current flowing here will be IS, and here is IA, and here is IF, and this is RF, and this is DS. So this is basically the it is equivalent circuit diagram of the DC shunt motor, equivalent circuit diagram of DC shunt motor. Now you can write the voltage equation from here, and the voltage equation would be like this. Okay, using Kirchhoff voltage law, we can write Bs equals to IARA plus, and this is we call as EB. It is called EB, and the subscript B is for the back EMF, so it is called BB. Now we can derive the current equation from here. Bs minus EB by RA equals to IA. Now this is our current equation, okay, in the DC shunt motor. Now let's analyze the importance of it using this equation. Okay, at initial the motor is not running. We supply the voltage Bs. The motor is not running, and we supply the voltage Bs. So if the motor is not running, then back EMF would be 0, because it is not rotating. Back EMF only exists when the motor starts rotating. So initially back EMF equals to 0. So our equation becomes BA equals to Bs upon RA. Now this is the problem. Why is this problem? Because let's say Bs is about 200, let's say we have our 15 volts. Okay, simple, and this is our RA, which is 0.01 usually. Generally its value is usually, and when we divide 15 by 0.01, then we have 1500 ampere. This is very high current, and what this high current does is it melts the armature wire, it melts the armature winding. Oh no, it melts the armature winding due to very high heat, Now this is the problem in the DC motor. At the starting since EBB is 0, and at running condition EB will be something. At running condition EB won't be equals to 0, rather EB equals is 5T and upon 60 and Z by A. You can know this equation from the generator equation. It is same as generator equation I have written. I won't give any derivation of this because this is would be the next video. And at running condition, EB won't be 0, and the current equation is V minus EB by RA, and these two terms are nearly equal. Okay, and these two terms are nearly equal, so IA would be less. So IA would be less, and that small IA will not melt the armature. So will not melt the armature. So in this way, back EMF helps not melt the armature due to very high current and very high heat. So in this way, back EMF is useful. Now there is not only one usefulness of back EMF, there is also another one, that is it acts as a feedback loop. Okay, it acts as a feedback loop. We know that motor can be equipped with either low load, that means, and high load, and due to the back EMF it can adjust its speed. Without back EMF it won't be able to adjust its speed. Now let's look at how it gonna be adjust its speed. Now I'm writing the same equation I have written before, and that is B, not actually E. I'm written wrong here. So let's use different color. That is B minus EB divided by RA. And now we also know that EB equals 5Pn upon 60 multiplied by Z by A. So let's say we have large load, that is heavy load. Large load means heavy load, and we know that to rotate the heavy load we need more torque, means we need high torque, and you should be knowing that torque is directly proportional to IA times phi. And what is this? This is the armature current, and this is the flux. Okay, so now we need high torque, so we need high current, and from this equation we can know that high current, how can we achieve high current? By decreasing the back EMF. So by decreasing back EMF, so in this way it acts as a feedback loop. So now summarize the things I have said. First, we have high load. For high load to rotate we have high torque. For to a high torque to happen, for high torque to happen we need high amount of current. For high amount of current we need less amount of back EMF, and less amount of back EMF would actually decrease its speed. So it can adjust its speed looking at the condition of the load, and similar is for low load case. At low load IA would be less, IA would be less means EB would be high, and EB would be high means speed would be high. So in this way we can relate it acts as a feedback mechanism. Now the next importance of the back EMF is reduce weight. Okay, as I already told that weight is highly dependent on the current flowing in the armature. With the help of back EMF we have low amount of current. With the help of back EMF we have low amount of current. So low amount of current means less cross sectional area of the conductor and less cross sectional area of the conductor means is we need low weight of the conductor, since weight is directly proportional to area into length, and this low means obviously the weight would be low. So the next importance is reduce the weight of the motor, and then next one is increase efficiency. Okay, and this is how I gonna tell you, and this is B minus EV upon RA. So we can, this is a basic equation, and as we when you look at the diagram of the shunt motor, you can show that voltage loss, there is voltage loss in armature, and that is equals to IA square times of RA. So we can decrease RA by increasing back EMF. So in this way, due to the presence of the back EMF, the IA is less. So less means less voltage loss, and less voltage loss means higher the efficiency. In this way we can increase the efficiency of the DC motor. So these are the benefits of the DC motor. At first we can know that low current, so first low current is maintained while the motor is running, not starting. At starting still there is high current because there is not back enough. And the second importance is acts as a feedback mechanism, and third and last is increase its efficiency. So these are the three benefits of the back EMF. Beside this there are many benefits, but today we only gonna take about these three benefits. So this is how the back EMF helps the running of the DC motor smoothly.